Fabulous. Thank you very much. Hopefully, yes, excellent. The lapel mic is working. I do have a tendency to wander, so I've got a lapel mic for this. So very delighted to be joining you all. Thank you for having me. And I've given this a somewhat grandiose title, Responsible AI for Human Flourishing, because in some ways this is the best kind of description I can find for the things that I do. But I want to start with talking a little bit about who I am and where I come from before I get into the actual research bits behind this. I gather that's a bit of a tradition of these talks. So I have a number of different hats. You can see them listed here. As Kat said, I'm an academic at the University of Sheffield in the School of Computer Science, part of our Center for Machine Intelligence, the leadership team there. I have a couple of government roles. I work in Skills England and the Government Office for Science, just declaring those for any conflict of interest purposes. But where I came from before I did any of that is actually a small town in New Mexico in the US. So it's a town called Raton. This is the lovely downtown of it. You can see it's a very large and happening place. It also happens to have its name in 20-foot-high letters on top of a hill overlooking the town, just in case you forget where you are. They light this up at night in neon, just to really make sure that you know exactly where you are. There are no other towns around for 30 minutes, by the way. So after growing up in rural New Mexico, I went to undergraduate at a small liberal arts college in Northfield, Minnesota, so another small town. I spent a lot of time living in small places. And this is an institution of about 2,000 students that really emphasizes sampling across different disciplines, sampling across different areas of research, different areas of knowledge, which you'll see why this is important in a little bit. But this really shaped who I am and the way that I work. So let me talk a little bit about sort of the broader trajectory here. So I did my undergraduate in computer science and Russian, because why not? Why not combine those? I did not, as far as I know, get recruited for the CIA. I'm still a little bit miffed about that. After doing my undergrad, I was a bit confused and lost, as one often is after doing undergrad, and went and did software development for a couple of years for a small company in Ohio, and decided this isn't really what I want. I want to be back in an intellectual environment. So I went out of the real world and back into an academic sphere, and I haven't left it since. I did a PhD at the Ohio State University, which is one of the largest universities in the US, where I studied, again, computer science. After that, I went to, not terribly far away, over to the University of Pittsburgh, just in the next state over, where I did a postdoc in biomedical informatics. So here, a little bit of a shift. So I studied computer science, I sort of focused on computational methods, ways of working with data, ways of developing AI technologies, and then sort of shifted through that process into the health space. Going from there, I moved over to this side of the pond. So I was able to secure a lecturer role at the University of Sheffield, at first in the information school, the Faculty of Social Sciences. So again, a bit of a shift, moving from computer science to health informatics to social sciences. And then a couple of years ago, we established this Center for Machine Intelligence, and I was able to secure a role as the AI for Health lead and broader theme lead on AI-enabled research. And this came with a move back to computer science. So it sort of pinged around a bit in terms of where I've been and what I've done. Now, along with this has come a lot of different government-related hats, shall we say. So I did research during my PhD with the National Institutes of Health Clinical Center, which is the US federal government's research hospital, with the Social Security Administration, with the Veterans Affairs Department. And then here I have, as I mentioned earlier, I have these roles with Skills England, Government Office for Science, and of course, as Kat mentioned, the UK Young Academy, which I'm immensely proud of being involved with, and all of you should look into. Now, I've given this to you in a somewhat linear fashion. But as you might imagine, this journey, pathway, has really looked a little bit more like this. So I am a very interdisciplinary researcher, as you might be able to guess from the sort of pinging around that I mentioned. And I was very excited to get the invitation to come and speak at Reuben because this is an interdisciplinary college. And I find that immensely exciting to see, very inspiring to see that there is a structural recognition of that. And interdisciplinarity, I'll talk a little bit more about what that means to me, but also talk about what it sort of has looked like in practice. So I ask interdisciplinary questions. I ask about the ways that we work with AI, the things that we do in the world with data, how it represents aspects of being human and what we can do. And I do so in ways that draw on all of those different backgrounds that I've had. So I bring in computational methods, I bring in health informatics knowledge and sort of applied clinical contexts. I bring in social sciences, I bring in a policy hat. All of these different methods, all of these different ways of thinking are different tools that enable asking different questions about these, about this sort of broader idea of AI and human flourishing. But that has come with a lot of different challenges and growth and sort of, let's say, growth points. So those of you who are of a more interdisciplinary bent, as I imagine many of you are, know that it can come with a lot of asking, who am I? Why am I here? What is it that I'm actually trying to do? And a lot of imposter syndrome. Quite a lot of imposter syndrome. I can tell you that earlier today, I was writing an abstract for a special issue, and sitting there, again, as somebody with a PhD in computer science, and I'm throwing out words like incommensurability and legitimizing agency around artificial intelligence. Now, and I'm sitting there thinking, who on earth am I to be writing about these kinds of very social science concepts? And the answer is I'm somebody who spent a lot of time doing those things. I've spent a lot of time thinking about those kinds of concepts, learning how to bring them into my toolkit. But part of what this journey of being an interdisciplinary person, researcher, policy engagement person, leader, what that journey brings with it is a lot of this kind of twisting around on yourself, twisting around in your environment and wondering, do I really belong here? And the answer is yes, incidentally. Anytime that you find yourself wondering that, the answer is yes. So just hold on to that. But another part of what has made this journey work and has shaped a lot of who I am is specific people who have been mentors, who have been friends, and who have been champions. And I want to take a moment to thank some of these people because it is, to me, a really important part of when we as academics, when we as leaders go out and present the things that we do, to also acknowledge and be grateful and express gratitude for the people behind us. So the people that you see up here who have been enormous mentors for me are David Libbenowel, on the upper, I don't think I have a laser here, but David Libbenowel on the upper left, who was one of my mentors in undergrad, Eric Fazler-Lucier, who was my PhD advisor, Beth Rash, who I worked with at the NIH and has been probably the single greatest mentor that I have had, Harry Hawkheiser and Carolyn Rose on the bottom, who were my postdoc mentors, and my partner, Anna, who is also an academic, a biologist, fortunately. Don't try to do the mixing people of the same discipline. But who has been a consistent champion and sounding board as I've navigated all of this journey. And so part of the reason that I'm highlighting this is also to say that one of the greatest gifts that you can give, one of the things that I see as one of the greatest values that I can offer as a leader, as an academic, is to try to be this kind of mentor, this kind of champion for the students, the trainees that I work with. If I can be one of these people for one person, I have done my job, and I can be proud of that. So, what has this journey, working with all these people, doing all these different hats, sort of bouncing around between things, where has that brought me? What I research is AI. It's a bit passé to say that now, but I research AI as a connector and a fragmenter between people, information, and practice. So this is the sort of thread that ties, and I will say, I have come to this articulation after about 10 years of doing this research and now being able to look back and say, that's what I was doing all along. Again, this is part of the experience of being an interdisciplinary researcher. So this is sort of the governing, the overall umbrella of what it is that I do. Now, thinking from that lens, I used the words responsible AI in the talk, or in the title. And this is a rather contested term, as all the best terms are. And so I want to give you my definition of what responsible AI means. And this is the definition that I and my collaborators use. So we think of responsible AI, brackets here, use of, because we're emphasizing the use and not just the technology, as AI that is used in an effective way, in an ethical way, and in a way that produces equitable outcomes. Now, mapping what each of these means and how you understand it, how you assess it, how you implement it in practice, that's where the research lies. But this is the overall framework. So when I talk about responsible AI, when you see responsible AI, think about these 3 E's. We want to be effective, we want to do the thing that we're setting out to do. We want to do it in a way that is ethical, and we want to achieve outcomes that are equitable. Now, I said this word practice, and I want to come back to this, because this is a really important part of the work that I do. A lot of what I'm interested in is how we do what we do with AI. You'll note this question, you can parse this in about 3 different ways. If you are a language nerd, you can structure this in 3 different structures. That's intentional, because that ambiguity is part of what I study. And I'm highlighting here, that is my arm if you're curious, I'm highlighting here an output from a project that I led a couple of years ago called FRAME. It was funded by the Arts and Humanities Research Council, where we were looking at what does responsible AI, this EEE thing, what does that mean to people and to organizations in practice? So we worked with partners across public, private, and third sectors, and we studied with them, when we talk about responsibility, when we talk about AI, what does that mean to you? And one of the key things that we did in that project was we worked with an art collective based down in Brighton called Blast Theory. They create interactive arts that really help us kind of reinterrogate how we interact with technology. And they, working with us as co-researchers, they developed this output. This is one of a series of outputs, which are responsible AI soaps. So you wouldn't necessarily think of soap when you think about AI, but a lot of what came up in our research was seeing that the kinds of things that people were doing with AI, the questions that they were running into, where responsibility became tangible, was not about the technical implementation. It wasn't about having the right kinds of guardrails within the system. That was part of it. But a lot of it was about the unglorious, everyday hygiene, the day-to-day practices, the things that people did, the ways that their organizations defined and implemented and managed policy. And we saw that the language was very slippery, and it would erode, and it would change over time. And so Blast Theory came to, with us, this idea of soap as a metaphor for helping us to think about what we do with AI differently. So I wanted to put this in front of you as a way to say that what this research looks like, what asking questions in this space looks like, can be very multifaceted and can take many different forms. And this is the most generative intervention I have ever done. We have taken this as we've taken these bars of soap as a workshop to 5 different conferences at this point, had people wash their hands and talk with us about, what does this make you think of about AI? And they're amazing conversations. So what I'm asking with this, what I'm asking with all of my work is, how do we do what we do with AI? So I want to take that question and zero in a bit on the human flourishing part here. A lot of my research has been in the area of AI and disability. So I'm going to take this sort of overall framing, these 3 E's of responsible AI, take this framing of asking, how do we do what we do, and show you what that has looked like in terms of studying this nexus between data, AI, and disability. So disability is, we often think about disability through sort of a special case lens, that this is something that describes a particular segment of the population, not necessarily relevant to us unless we fall within that segment of the population. That is not true. So based on official statistics, and the methodologies differ, but you can generally estimate between 1 in 5 and 1 in 4 people are officially designated as disabled by their governments. And we know that these are a drastic underestimate. Realistically, you're looking at probably more like 1 in 3, 1 in 4 people in the world is currently experiencing some kind of disability. Pretty much all the rest of us are also working, we have family members who are disabled, we work closely with colleagues, with friends who are disabled. This is an everyday experience. And disability is also in everyday experience. This isn't about medical conditions. This isn't about saying, so I'm neurodivergent. It's not about saying I have this particular condition. It's about saying, here's how my neurotype affects the way that I think, affects the way that I work, affects the way that I interact with people. So we think about, one of the ways of thinking about disability is through this lens of functioning. And functioning describes, it's what you do at home, at work, out in the community. So we can think about disability in terms of this lived experience, in terms of I am a human being interacting with other people, interacting with an environment, trying to do things. What does that look like? And when we think about disability in that way, what we see is that experiencing that tends to get lost in the digital systems that we have. So we have this sort of wonderful world of the complex, ineffable nature of experience. We want to capture that as much as we can, and we don't. We're constantly losing important information about what it means to be disabled, what it means to live as a person with a disability, to experience the world around you. So there are many different kinds of technical barriers that happen to this. There are many different social barriers that lead to this. We can think about tackling those barriers with intelligent design of data and AI systems. And by intelligent design here, I mean really thinking about what is it that we're trying to capture? What are we trying to represent? What do we want to do? And how do we want to do it? So we can start, we're never going to be able to close all of it. You cannot capture human experience. But we can get a lot more than we have now by thinking about, how do I capture a person's individual perspective? Maybe I ask them. Maybe use AI technologies to help analyze what I get back when I ask them, and so on and so forth. So one of the key things that we've been looking at in trying to sort of close this information gap is looking at text. I'm a language nerd. My background is in natural language processing. So text is the best way of capturing multidimensional information about lived experience. What do you do when you want to tell somebody about something you've done? You talk to them. You say words in natural human language, and you can describe what it felt like, what you did, what challenges you ran into. That's what text helps us to capture. So we can use textual information to help get at much more of this lived complexity of a person with functions and structures inside you, doing things in an environment that may or may not support that process. We can capture these complex interactions with information that is recorded in text, at least in theory. So I led development of a natural language processing pipeline to help analyze this information, so to be able to find what we term functional status, so observations of outcomes of performing specific activities, individual people performing activities in particular contexts. So we built this pipeline to help analyze functional status from text. So the idea is you have this note, say you go to your GP makes, you say you hurt your knee, it's making it difficult to walk, your GP makes some notes, that's where this comes into play. So we're going to take the note that is written, extract from it, here are segments that we think are talking about some kind of functional activity, and then map them to a standardized reference so that you can organize it and find it. So if you want to find what's all of my evidence that about this person's level of performance in walking, for example, you can do so. So here we're using a standard international reference called the International Classification of Functioning Disability and Health, or the ICF. Okay, we built the technology. That's not really the focus of this. How did we do it? How did we get there? Let's start to wind this wheel back. How we got there, how we got to this point of we've got a problem, now we've built a technology for it, is these 4 stages. So there's annotation, there's the creation of data so there are data that are collected, and we create on top of that, hey, this note is describing functioning in this place, this is the category. So that's a process of annotation. Then we used machine learning to help develop these 2 different stages, so the extraction and the linking. So being able to say, here's where in the text this information is, and then map it to your standardized reference. And then there's an evaluation step. So we always need to ask, how well did we do? Did we capture what we were interested in capturing? And so each of these steps involves some quite significant decisions that shape the impact, that shape the effect of the technology that we built. So let's start to wind that back a little bit and see what I mean. So functional status information is complex. It's semantically, syntactically complex. These are typically full sentences where you have a subject, you have a subject, a verb, and an object, sometimes an object, but certainly you have a subject and the action that they're performing. So here, moderate difficulty walking 300 feet in clinic with cane is one observation. This is one performance of a functional activity. Now, if you happen to have a background in NLP, you might look at this and think, well, okay, fine, we can use sequence modeling. We can try to build a model like what a large language model does that says, let me just find the right sequence of words and say, hey, this is your thing. It doesn't really work in this case because these are very long and complex, and we don't necessarily care as much about all of the words in it. So what we did instead was we built a word level model. So we're going to go through a note, go through a document and say for each word, is this part of a description that I'm interested in or not, and then do some post-processing on top. So we have to ask, how do we know if we got it right? I've got my reference, I've got my predictions. How do I compare them? Well, I can go the straightforward way, and let me just ask, did I get all of the right words? I've got an annotation. This is what I should be recovering. Did I get all the right words? And the outcome of this is not great. What we built is kind of crap. It's very noisy. So it's good at finding the right thing. It doesn't miss too many things. That's why we have high recall. But a lot of the things that it says, hey, look at this, are wrong. So the precision is low. But here's the rub. This isn't the task we cared about. This research was done with the NIH Clinical Center, with the Social Security Administration, looking at AI-driven ways to help support Social Security's process of reviewing eligibility for disability benefits. That means you've got a human who is reviewing large piles of evidence, and our job was to help them do it faster, help them find the right evidence that they needed faster. And when you've got 1,500 pages of evidence, as was not uncommon, that can be quite helpful. So I don't necessarily, I've got human eyes to rely on. I don't necessarily care about finding all the right words. What I care about is putting the right documents in front of them. And when we look at it in that lens, we're actually doing pretty well. So the system is noisy, but we're able to rank things in the right order. So this Spearman's correlation on the left means that we're able to put the documents in approximately the correct order based on the amount of relevant functional information in them. And 0.83 is quite high. So we're able to do this pretty near perfectly. So for our goal, for the thing that we're trying to achieve, we're actually doing this pretty well. Now, so that's looking at that last step about evaluation. And what I'm illustrating there is not just that, for this particular case, okay, we had terrible experimental results, let's rejig it to say it was great. That wasn't really what we did. But the important thing is here, we had to ask the right question in the evaluation to tell us what we actually cared about. So having a standard evaluation, there could be other ways of doing it, depending on what you're interested in. Now we can take that same idea and look at the design of the technology itself. So let's wind back again, thinking about the extraction and the linking stages. We're building technologies. How do we build those? Well, when you have data and a thing that you're trying to achieve, something that you want to learn from those data, there's a lot of different ways that you can do this. So we work with large language models now. LLMs are largely based on a particular architecture called a transformer. The transformer has some very nice properties that help it be very high fidelity in modeling very long sequences of text. It also makes it incredibly computationally expensive, but that's not the thing that people are focused on. But there are a lot of different ways. There are a lot of other ways to do that problem, to model what is the likelihood of a particular sequence of language. So in this particular case, we could have designed these technologies quite differently. And for a different goal, we certainly would. And those choices that we make impact the role of that technology, what it does. It impacts who it affects. So we put together this framework for trying to start decomposing what are the decisions that we made in building a particular technology. So thinking here about sort of these two different layers of the scope, what is it that you're trying to operate on, and then the conceptual specification is what is it that you're doing. So at the scope level, there's operationally, what are you working with, and then what purpose are you trying to serve. So for example, what kind of documents are you working with? Whose goals are you trying to serve? And then you map that to, okay, let me think about what data are available for me to use, what use am I trying to build this thing to do, and what then does that mean about actually building the thing? So this is basically modeling the process that an AI expert would go through to be able to say, you've got this problem, let me build you a solution. So in the case of this work with NIH and SSA, if you're going to develop critical methods, always apply them to yourself first. We can take a look at this and say, okay, our operational scope, what we were interested in applying to was these two things, activity and participation and medical information. But in this case, Social Security already had people in place that were working with the medical information. So for a completely non-scientific reason, we scratched that. That part wasn't part of our process. But that affects, then, that non-scientific reason affects the science that we did. The application scope here, we're interested in multiple different kinds of records, so health records, social records, administrative records, fine. Data, what we have available. Now, if any of you have worked with health data, you know that most health data is structured. You're getting lots and lots of numbers, you're getting lots of readings, you're getting lots of test results, and so on. We didn't have any of that. We had free text. Because the way that Social Security works is they print out your record, they scan it, and they fax it to Social Security. I am not kidding. So what that means is for our technology development purposes, what we have is everything is text. Even the stuff that's not text, we see it as text. Our use case is searching and ranking documents. And so what all of that means is we're going to build this technology the way that we did, as text highlighting and then being able to do coding and classification. Now, if any of those had been different, if any of those situations or different aspects of this had changed, we would have ended up with a different technology. We could have made different choices at each of these points. And this gives us a tool to be able to trace that and to be able to say, if you had done it differently, if the situation had been different, what would that produce on a technology? What impact might that then be able to have? We can do this as well, rolling back a bit further. So before we get to the technology, where do the data come from? What are the data that we're trying to work with? Well, we can ask sort of similar questions here. If you have something that you want to represent, a data subject, you have a person, you have a situation, you want to be able to represent something about it. That's what we do with producing data. Well, there's a lot of decisions that go into producing data, and many of them are not visible. So if I say I want to represent somebody's functioning, how do I define it? What's my conceptualization of what functioning is? What of that is actually observable? So if I want to think about somebody's cognitive reasoning process, you can get some good proxies for that, but you can't really observe that directly. So parts of that become unobservable. You just cannot get those in data. Then of the things that are observable, we're only going to choose to observe some of them. We're going to choose what we measure. And then of what we measure, we always lose some of that information in recording. Now, colleagues at the National Physical Laboratory would probably throw their hats at me for saying that measurement is lossy, but well, no, they wouldn't, because measurement is always lossy. So at each of these points, you're making specific decisions that lead to a loss of information about the thing that you're trying to represent. So here again, we can look at, got a little bit of a text overlay here. Here again, we can look back at what we did with the NIH and SSA work. What we're interested in is activity and participation and medical history. At this stage, fine, we're interested in both. What's observable from these? There's a lot of activity and participation that isn't directly observable. But you can get personal experiences, you can get medical measurements. What is measured, and I'm noting here, we didn't choose what's measured. We're working with other people's data. But we can trace these questions. We can trace what did they choose to measure. And they didn't choose to measure context. They didn't choose to measure, there's no datafication that represents, I'm giving this talk in a hall that looks like this to an audience of this size and composition. It's just going to be like physiological measurements. So we lose that context, but we get things like medical diagnoses, we get rich medical data. And then of what is measured, only some of that is recorded. Most of it is, but some you lose. So you lose some information about functional experience. You just get sort of standardized tests. So what all of this means, when we take all of this, when we continue this sort of winding back process, and we go from, we've done a thing, how do we evaluate it? What does that actually tell us? How do we build it? What does that mean for what it can do, what it can't do? How did we even think about the data in the first place? What perspectives do those data impose on us? And how can we choose to work with that? What we start to see is these things here, that when you approach these questions of defining function and disability, which, as I said earlier, are highly contested topics. There are many different ways of defining and operationalizing what each of these is. And anytime there's a difference, you're going to get different and incompatible data systems and AI systems. But we don't necessarily make that visible. We don't necessarily say, this is how I'm defining what disability is. Because we assume that everyone shares the same concepts. Making these decisions, designing these processes of capturing data, standardizing data, is an exercise of power. Those choices that are made, those choices are made by powerful political entities. In this case, it was the Social Security Administration and legislation written by the US Congress that sets their statutory requirements for how they define disability. That is very much an exercise in power. But this is also at the micro level. So what is your GP deciding to record? There's an exercise of power there as well. They have the power to decide, what is it that I'm going to observe, what is it that I'm going to measure, what is it that I'm going to record. And so as we wind each of these back, we start to really see that data and algorithmic processing, I don't know how true it is to say that they're perceived, but they're certainly often presented as neutral, as authoritative, and as true. And they are none of those things. Each of these stages, every data system that you interact with, every algorithmic system that you interact with, is the result and the product of a series of choices, and a series of design decisions, a series of exercises of power. And to understand what the impact of those systems looks like, what possible alternative futures, alternative visions of those systems might be, being able to trace those histories makes that tangible. So I'll talk just a little bit about some of the work that I'm doing now, taking this and moving it forward into the policy space. I'm running a project at the moment looking at the use of AI in education for children with special education needs and disabilities, or SEND. Many of you will likely have seen, it's been quite often in the news recently, there's a lot of sort of dire prognostication about the SEND landscape, rates of different approvals for different levels of education support requirements have been going up, rates of diagnoses of conditions that are amenable to SEND support have been going up for many different reasons, very few of which are population epidemiology. And what this is creating is an enormous amount of burden on the local government sector, on government spending that is allocated based on old expectations of SEND needs and is facing vastly updated ones. So there's a lot of use going on of AI in education right now. There are a lot of people involved here. When we think about how use of AI is being shaped in the SEND system, you are looking at many, many different stakeholders that are all interacting with one another. So when you think about this sort of network of influence, network of people and organizations that are involved, and you think about those design decisions and who is feeding into those, you can start to see this combinatorial effect where the choices that are made about how will AI be used, be defined, be implemented, be operationalized, start to multiply. And we start to get this sense of many different competing visions of what AI is, of what impact it's meant to have, and of what that looks like in practice. So we're running a couple of surveys right now, one working with professionals, so local authority professionals and education professionals, one working with parents and carers. Excited, somewhat apprehensive to see what these surveys will yield, but what we're looking at here is asking some of these questions about how do you understand this use? What benefits do you see? What risks do you see? How can we start to map this different network of stakeholder perceptions and start to understand what shaping responsibility in this space might look like? So let me take just the last couple of minutes and wind back up to this interdisciplinarity piece. What I've just talked you through has been drawing on a lot of different methods, a lot of different ways of thinking, and ways of thinking about knowledge, ways of thinking about people. Part of the challenge of doing this work, and part of the joy of it, is thinking about AI in a few different layers at once. So computationally, we tend to think about AI as a linear process. You have input that's going to an output. This is what we do as engineers. When you think a little bit more in an applied context, my work in health informatics, it's not really linear anymore. Now it's cyclical. I have a clinician. A clinician is seeing patients. They're using AI. They're helping make decisions. Then they're seeing the next patient. What does that more cyclical process look like? And then as a social researcher, I'm thinking about something different again. I'm thinking about the wider networks of power, the contextual factors, the regulatory context, the oversight mechanisms. I'm thinking about who is affected. All of these are true at the same time. And all of them require and use and leverage different methods and different ways of thinking. So there's this really interesting process here as we're investigating these questions of responsible AI, of holding multiple disciplinary framings at the same time and letting them be in tension with one another. Tension is not a bad thing. It means there's something interesting that you can look at. So part of what has come out of this is I've developed this framework, this sort of high-level conceptual framework called AI thinking, that's trying to start capturing what are all these different questions that you ask, how do they interact when you're doing an AI application, whose knowledge do you need, how do you get them to ask questions that can be shared. And I've been doing a lot of work with people. So I said I do a lot of social research. This is a lot of what that looks like. I've been running a lot of workshops. I'm running workshops right now with local authorities, working on developing what a sort of set of responsible AI skills and practices in the local government sector looks like. This is the larger blast theory. Constant washing machine is the name of the output, the artwork. product. I've also published last year a handbook of responsible AI for research funders, coming from a lot of really intensive engagement with them. And all of this work, all of this sitting down and talking and asking about, how do you understand these questions? How do you ask these? What do you think and what do you see, and how do you work? How do you do the things that you do with AI? That is what has led to all of these different ways of thinking. I also want to thank and acknowledge there's an enormous village of people who are behind all of this. This is by no means just me. I think I've captured everybody who's a co-author on the things that I've cited here. There are many other folks who I've worked with. I want to say an enormous thanks to my research team as well, the folks who've worked with me currently and in the past, postdocs, PhD students, and as interns, including one Reuben student last year. And I want to say a thank you to various different sources of funding that have supported this, both in the US and in the UK. So I will leave you with these two questions to think about as we dine. Keeping all of this in mind, or bringing your own perceptions and thoughts, what would responsible AI look like to you? And if somebody puts something in front of you, how do you know if it's responsible? How would you define that? And the second question is, how do you see? So I've focused on disability. There are many other kinds of contested experiences and identities. I'm also queer, as you might be able to guess. This is also a very contested space when it comes to working with AI. How do you see contested experiences and identities interacting with AI, and what would you do to shape that interaction? Thanks very much.